months ago. They have a very young and creative team, and they're really working on a problem. It is a real problem, how they deal with the real data and analytics with the multi-sources and how they interact with them. So give our applause to Plamen. Let's see what they do.
Thank you. Thank you. I'm really thrilled to be here, guys. I didn't expect to see so many data people, so thank you all for coming tonight. Okay, let's dive in. That's not the first slide, though. Okay. So my name is Penev. I'm the co-founder of Yatrus Analytics and the chief product officer as well. I love data. I deal with data every day, and I'm growing more into it as well. Now, what I'm going to we'll be talking to you about is real-time data analytics. And let's just dive in, shall we? So Yatrus is building a platform for discovering early market-moving information by using non-traditional sources for hedge funds and investment banks. Now, what do we mean by non-traditional sources? We mean especially social networks and open data. Let me just give you a couple of examples so that you can get a sense of what we're talking about. Those are two graphs showing, firstly, a tweet by Hillary Clinton in which she was condemning a couple of biotech companies by saying that their products were overpriced and their research and development has been flawed, which took their stock prices by something like 5%. While this is here Elon Musk, I'm sure you all know about it, the Tesla CEO, who by making an announcement on Twitter managed to raise his valuation by 900 million just by a single tweet. The valuation of Tesla Incorporated was raised by 900 million. Now, in order to get to all that interesting real-time analytics, we need to look at the larger big data landscape before. And I really think that this panel tonight is a great example of the big diversity that the big data landscape is presenting. So, as we saw at the beginning, Transmetrics is representing the Internet of Things part of big data, the machine data, sensor data. We just saw a representation according to Alexander Mamouti, which was talking about the architectural and infrastructural stuff from big data. We, at Yatrus, we represent the social side of data, the social networks and human-generated data. So, since at the beginning I saw that a lot of people that probably have read at least one article about big data, I'm not going to go too deep into those things. You know the three V's, you know volume, velocity, and variety. So you know that 90% of the data in the world today is being created in the last 2 years alone. The problem that I want to emphasize on, though, from the three V's is the problem of variety. Because that's the problem that we at Yatrus Analytics are really concerned with and trying to work towards solving. So, what is the problem of data variety? Well, simply, it's data is everywhere, and it's in all forms, in all structures, and in all formats. And it is very hard to be able to combine disparate data sources and to be able to ask questions against them as a whole, so that you can integrate them and ask bigger questions against more and diverse data sources. These are just a few of the examples of the industries that are already doing great things with big data. I'm sure you know about marketing and personalized advertisement, cybersecurity as well. Agriculture, they're doing great things in the stage right now actually with predictive analytics, combining weather data, soil, air quality data, and sensor data as a whole. So the problem of data variety is that it is not easy to put data into context. Now, data on its own is meaningless. It's just some numbers. It's the context and the sources that it came from and how it was generated that give it any sense and meaning. And that's the challenge in front of us. We need to put data into context, and for that task, semantics seems to be the solution. Now, What is semantics? Semantics is the study of meaning of human language and human expression. But in this case, we're talking more specifically about semantic ontologies. Now, can you raise your hands if you know what an ontology is? Okay, that's great. Okay. So I'm not going to spend too much time explaining them, but as a whole, a semantic ontology is just hierarchical, structured description of a domain of knowledge. Now, a domain of knowledge can be a particular science, for example. So, I think the best example I found the easiest to understand is the animal kingdom. So, you know the animal. You have mammals, you have plants, you have vertebrates, you have fungi, and under those you have subclasses, you have instances of animals. Now, that's the basic idea. You can represent almost any domain of knowledge in that kind of hierarchical structure. And this tool of semantic ontologies really turns out to be the key to putting data into context and to trying to solve data variety. I think the easiest parallel that I'm making, at least for myself, it could be far-fetched, but it's the fact that semantics and ontologies are what are for machines, what human language and mental models are for us. Because through language, we get to classify the concepts, we get to classify everything around us, and through mental models, we get to put that in a structure. So you all have in your own fields, be it computer science, be it mathematics, you have your own ontologies of the fields that you're dealing with. So, and you can really create an ontology about anything. You can create an ontology on an economy, or an industry, or a specific company as a whole. Now, ontologies are really useless on just on their own. So they really become useful when you get the actual data in them, so that you fill up the structure with instances, and you put them in an actual database where you can query them. When you put them in an actual database, you get what is known as a knowledge base. How many of you have heard of DBpedia or Freebase? Okay, that's all right. So they're part of the linked data initiative, which actually began, I think, in the 90s, started by Tim Berners-Lee, who was one of the founders of the World Wide Web, who proposed the idea of the semantic web, where machines will be able to actually understand every facet of human communication, every part of human language, and will be able to understand the meaning behind it. That's the idea behind a knowledge network. Now, the thing about ontologies is that they can be roughly two kinds. You can either have a very domain-specific ontology, or you can have a very generic one. Now, in the case of DBpedia and Freebase, they are very generic ontologies. So you can have at the top of them classes like people, locations, organizations, companies, and going in subclasses within that. While a very domain-specific ontology would be, for example, an ontology about cardiology, with very specific terms, with very specific relations. We at Yatrus try to combine those open source knowledge bases like DBpedia and try to combine them with very specific financial ontologies that we created. Now these are all actually knowledge networks that are open source and that you can access. The points actually showing the different references that the knowledge bases have. So if this knowledge base is using some classes from DBpedia, that's why it's pointing towards it. As you can see, DBpedia is the most used one. And you know why? Well, it's basically because it's the representation of Wikipedia. And I'm sure you all know about Wikipedia. That's Wikipedia is put into a structured hierarchical network, and it's called DBpedia. Okay. Now, the thing that combines all those elements of data variety, context, semantics, and knowledge networks is a project called Watson, IBM Watson. What Watson started as was a natural language processing engine. Now, natural language processing is one of the fields under artificial intelligence. It's basically the field that gets to process natural language. It analyzes all kinds of text to different operations. It classifies different words. It does part of speech tagging and other kinds of operations. classification as well. So Watson was the project that combined all those and that kind of gave us the understanding that this is at least the right step in solving the data variety problem. The other thing about Watson is that it's using a lot of those big data architectural platforms that we already talked about. So I'm not going to spend too much time on those. The spine of our system, that is the system that we're building, is Spark. We started with Hadoop as well, but we realized that for real-time analytics, what we're trying to do, Spark was really the tool that was needed. There are other great tools that are advancing real-time architecture, like Cassandra, that's actually a Facebook database. Druid, Storm actually fell down a bit now in the last few months because it's been pushed over by Spark. But yeah. Now, let's get to our case. How many of you guys have Twitter? How many of you guys have Facebook? Yeah, okay. Now, I know Twitter is not that popular around here, but it's really booming in the western part of the world, and especially in the United States. Now, here are a few of the Twitter facts that you can have. There are 400 million active users. There are 500 to 700 million tweets per day, and it's really that kind of a culture among at that part of the world where you get to observe something, you get to see something happen, and people's first thought is, I'm going to tweet about it. So that's really a thing. So I didn't believe it at the beginning either. I didn't think that it's that kind of a social network where events can be discovered from, but it really is. And I've grown to believe that even more. Now, the other thing about Twitter is that its whole purpose is real time. So it's whatever comes at this moment. And the two industries that living and breathing on real-time information are media and finance. Those are the two industries that we as a company are focused on as well. Now, for media, obviously, because they need to be the first to report about an event and to say that an event has occurred. And for finance, well, simply because markets move within nanoseconds, and they need to know every event that could possibly influence their portfolios, the companies that they are interested in, all the commodities as a whole. Now, the other part, besides Twitter data that we are focusing on, is open data. Now, open data is basically data that anyone can access, that can use, and that can download. And we're talking about some variety here, because there's a lot of data that's being opened by governments, by local municipalities, administrations. There's a lot of data that's being opened by internal companies' data. There's a lot of scientific wellness data, and so on and so forth. Now, what we are trying to do really is we're trying to get that open data, and we're trying to import it into that knowledge network that we're building, that I was referring to before. And we are trying to create the context around events that we are finding out from Twitter. Now, let me explain. The flow is the following. We have data from Twitter. Right now, we're utilizing around 30% of Twitter. We're not utilizing the whole Twitter, but we are very careful on our data collection rules. So we are trying to fine-tune those so that we can collect data that actually matters and data about events that are actually going to be influential to markets. What are those kinds of events? We're talking about social unrest events, we're talking about protests, we're talking about natural disasters, we're talking about reactions by influential people, like the ones I showed you at the beginning, like politicians and investment people. You know, a funny thing about Twitter is, you know, who is the most followed person on Twitter? It's the Pope. He has like 5 accounts for every language, and he doesn't follow no one though. He's here. He's just here. He's just here. So we're trying to discover events that are influential to markets and that will become news. We want to discover news before it's news, and we want to get information that will move markets before markets move. That's the basic premise of the system that we want to do. So, I was on the flow. We have Twitter streaming all the time. On those tweets, we're doing natural language processing operations. So we try to extract the different entities that are within the tweets. So for example, we want to see in every tweet if a company is being mentioned, if an organization is being mentioned, if a specific person is being mentioned. How do we do that? We do that by name data recognition algorithms that take those tokens and throw them to that knowledge base that I've been telling you about, DBpedia, for example. So you take a name like Barack Obama and you throw it to DBpedia and returns that it's the US president that was born whenever and so on. That's one of the operations that we do on Twitter data. Besides that, we try to add other features like to be able to cluster different tweets based on hashtags, based on user reputation. Based on user locality. So for example, if I'm tweeting like there's just been a crash on Tigras or Chaussee and my location, because you can get actually that kind of data from Twitter, and my location is in Bangladesh, I'm obviously not really referring to an actual event. I'm lying, obviously. So that's the kind of thing that we're trying to catch because it's very tricky. Twitter data is noisy. It's very noisy, and it is very hard to actually find credible information and extract credible events. And that's what we are pushing for. Now, after you've gotten all those natural language processing operations, we get to network analysis. Now, the whole idea behind a network analysis. Now, let me put it simple. Our system is designed to discover events and then to give to the user the ability to explore more information around that event, about the context, about the people that are involved in that event, about the companies that are influenced by that event, and how this event is going to actually influence other companies that are not involved in the event itself directly. And the best method to do that is actually network analysis. Now, I'm going to give, you can't really see that, I know, but you can see the dots, they're actually edges between them, you know, you don't see them, but it's okay. I'll give you an example. So, there was an event a few months ago in Mexico. There was oil refinery by ExxonMobil that blew up. There was an industrial accident. It was on Twitter very soon after the event happened. It was actually before news media had reported it. And that event brought ExxonMobil's stock by something like 15%. But it wasn't only ExxonMobil that was influenced. Why? Because ExxonMobil was part of a supply chain network that is that includes many other companies that are waiting on that oil from that Mexican oil refinery. And that's the kind of connections we want to be able to get. So it could be an event about this company and this company, but in fact, the companies that they're connected to might be much more influenced by the event itself. And that's what we try to explore through network analysis. The other real big thing about finance is sentiment analysis. Now, how many of you guys know what sentiment analysis is? Yeah, so it's basically being able to say if the text that you're looking at is having a positive, negative, or a mixed connotation. However, this kind of data turns out to be absolutely crucial for financial markets, and they're really realizing that more and more. Why? Simply because finance and financial markets and trading is not really based on the values of companies. It's based on social psychology. It's based on how people work, how people's minds work, and how ideas flow through society, and how the perception of certain companies' values is being represented. So the thing about sentiment is that you can get a lot of it in Twitter because everybody has an opinion and everybody wants to share it. So it's very easy to get sentiment data, but it's very hard to go deeper into it. Meaning, right now the state of sentiment analysis is you either have -1, +1, or a 0. So you don't really have the enormous spectrum of emotion that is represented within the text. And that's what we're trying to push forward to. Now, you can see on this graph the spectral emotions that we're trying to get into when we're analyzing text, and bullish and bearish are actually financial terms. It's basically when the sentiment is bearish, it's going back, so drop it or sell it or whatnot. When it's going bullish, you can buy more because it's going alright. So yeah, that's one of the areas besides network analysis that we are really trying to push forward. Okay, so our approach and our whole analytical framework and approach as a whole towards this kind of things has been influenced a lot by this guy, Penev. How many of you have heard of this guy? Yeah. He's he's leading one of the best MIT labs. It's called Human Dynamics, and he's really one of the most influential names in big data, and especially in the study of complex systems. Now, have you guys heard of complex systems? Raise your hands again. Okay. Complex systems is an interdisciplinary field that combines economics, sociology, social psychology, ecology, political science, and as a whole combines a lot of different disciplines and tries to take a different approach towards studying complex systems. So until now in science, the paradigm has been reductionism. Reductionism is you take a system, you take a component of it, and you try to understand it by understanding its attributes. You take it in isolation and you study it. That's the paradigm that was studied in chemistry and physics as a whole. But right now, complex system is saying now that's not enough. You cannot just look at a particular component of the system, understand its attributes, and then claim to understand the whole system. You need to look at the whole system, and more importantly, you need to look at the interactions. That's the key word here, and the interactions between the components. Some examples of complex systems, well, you have ecosystems. Your brain is a complex system because it's 100 billion neurons communicating and interacting at every second. Societies, economies are complex systems. And the real big thing about complex systems is that until now, it had not been able to study them in that way. Why? Well, simply because we didn't have enough data. But now, with big data, we do have enough data to study them, and that's why this field is being pushed further on. That's his book. It's a great book. He calls it social physics because of a 17th century guy who thought that we can understand society through computational social theory, but complex system is the paradigm behind it. So network analysis, as I already spoke about, is one of the main tools that that complex systems try to utilize. Why is it so important? Well, because it's a very good representation of interaction. So we have components, you have the nodes, and you have the links between them, which represent the interactions. The other very nice tool that we are trying to apply to markets and to analysis is fitness landscape. That looks a bit funny, but it's actually a tool from evolutionary biology. It was used to understand how well species are adapted on a particular landscape. Now it's being used to understand how well different companies are doing on a particular landscape. That's a market. And the higher you are on the landscape, so if you're on the top hill, the better adapted, the better fitted you are in the case of species, and the more profitable and the larger market share you hold in the cases of finance and markets. We're far from that, but we're pushing it hard because we really think there's a lot of potential. Okay, so a few conclusions. Now, we've been through a lot of challenges with Spark and with the knowledge bases that we face. Now, firstly, Spark is a great tool. It's really amazing, but it's very generic and it's very hard to fine-tune it towards your particular use case. And that took us some time. Now it's working, so it's all good. The other thing that we have found is that knowledge bases, because we want to use that knowledge base so much, it's been hard to query it the way that it's being given as a public API, for example, Wikipedia. So we have tried to raise it up on our own instance and to optimize our query time towards it. The other big thing that we learned was about network analysis and graph as a whole, which is not easy at all. But right now we're in real time streaming data, and you can actually go on and check our demo. Right now we are focusing even more on financial criteria, because the feedback that we've gotten is that the system that we're building is really going to be useful to financial guys. And as a whole, guys, it's been a great journey so far. We've been in business like for 7-8 months. We just had our prototype done. We have a long way ahead of us, but we know where we're going. There's a lot of work to be done, so let me just tell you, Yatrus is always looking for dedicated people. And as a whole, I really think what you saw on the first slide, where data flows, knowledge grows, that's the kind of motto that we really believe in. And I think that we try to share that with, I want to try to share that with you all. And I think that the whole big data thing is an enormous ocean that we are just starting to utilize and to explore truly. And well, I hope of where you want to go for a second. Thank you very much for your attention.